In this video, I'm going to be talking to you about linear programming. It's an application of systems of inequalities, and I just really like to let you know that math is useful. And I want you to start off by, if you can, printing the linear programming handout that I posted, and then the project consists of you completing the handout, including the example that we're going to do together right here, and then going in to the MyLab math course and completing the 4 problems that I posted in there, okay? And here's a template that can be used for the 4th question, okay? All right, so let me go ahead and talk to you a little bit about linear programming. So it's widely used. It's a really neat tool that can be used when making a lot of business decisions, okay? All right, so for the notes, okay, start off by just saying that linear programming is a method, I guess we don't need a capital P there, okay, is a method for finding the maximum or the minimum of a quantity that is subject to various limitations or restrictions, okay? There's a lot of terminology with linear programming, so that's kind of what the notes page does. The objective function, okay, is the algebraic expression in 2 or more variables that describes the quantity that we want to maximize or minimize, okay? So sometimes we're trying to maximize profit. So common examples are profit, which we would be trying to maximize, and cost, which we would be trying to minimize, okay? All right, so a system of inequalities is used to represent the limitations, or what they call constraints, on the function that we're trying to maximize or minimize, okay? So we might have, if we're in a company that's trying to make something, we may have limitations to how many employees we have or how much material we have. And so we have to consider all of that stuff to determine how many of this object we are going to be able to produce, okay? All right, the points in the shaded region. So when you do your system of inequalities, you get stuff that looks like this. We just did that in the previous video, and then you might have this like region sitting there. And it turns out that shaded region represents all of the ordered pairs that satisfy all of the constraints, all of the limitations or the restrictions. So these ordered pairs satisfy the constraints that you have on your problem, right? That shaded region is sometimes called the feasible region, okay? All right, so an important idea, this is like the big idea of linear programming, is that the maximum or the minimum value of the objective function, so like of the profit or the cost, will occur only at one of the corner points. Sometimes those are called vertices, so I'll use both of the languages here. The answer to the question is going to come from one of the points at the corners of this feasible region, which will turn out to be a polygon of some sort, okay? So it's kind of amazing because you boil down your whole big problem of determining how many of objects of one object or the other you should make. You boil it down to just looking at maybe 4 or 5 ordered pairs instead of infinitely many. So it's pretty remarkable. All right, and then in this area, you can read these on your own later, just kind of outline the steps that you use when trying to solve a linear programming problem from beginning to end, okay? And we'll work through these steps in this example that I'm going to do with you right here, okay? So let's go ahead and just do the example. All right, so here's the situation. So here's a company that's manufacturing motorcycles and bicycles. To stay in business, the number of bikes cannot exceed 4 times the number of motorcycles. They lack the facilities to produce more than 100 motorcycles or more than 240 bicycles. And already you're probably like, oh my gosh, how am I supposed to remember this? Well, you're not. You're supposed to do a quick read to see what's going on, and then you kind of start setting it up and working with it piece by piece. Okay. The total production can't exceed 300. If Yawaka makes 1,260 on each motorcycle and 350 on each bicycle, how many of each should be made to maximize the profit? So in other words, they make a profit of 1,260 on one motorcycle and 350 on one bicycle. We're trying to determine how many of each of these we could make, okay? So what you saw earlier in the problem, like from here, the to stay in business and talking about all of that up through there, those sentences are the limitations or the restrictions. And these could be due to your number of employees or the space that you have. Okay, but for whatever reason, they can't produce more than 100 motorcycles or 240 bikes. Okay. All right, so what you really do is you do a quick read, and then you get to the end where it says how many of each should be made to maximize profit. And that pretty much tells you what you should let your variable stand for. Okay. So we might just say they manufacture motorcycles and bicycles. Let X be the number of motorcycles, say. And let's let Y be the number of bicycles. Okay. All right. What I got to do now is write an expression for the objective function. And in this case, the objective function is profit. We want to know how many of each should be made to maximize profit. So that means profit is the objective function, and we're trying to maximize it. So the expression I'm going to write is going to represent the profit we would make. So this would be the profit. We would make $1,260 per motorcycle. So if I multiply 1,260 times X, that's what I would earn on the sale of however many motorcycles I make. And then 350 Y, that would represent the profit on all of the bicycles that I make and sell. Okay. So we just hang on to that. We're just kind of going through the process, kind of taking what's in words and changing it into math. We're just mathematizing it. All right, now it says to write the system of linear inequalities describing the constraints. Okay, so we just take these piece by piece. The number of bicycles, that's Y, cannot exceed. That means it has to be less than, could be equal to, it just can't be more than, cannot exceed 4 times the number of motorcycles. So Y has to be less than or equal to 4X would be the first sentence. Right? Then they say they lack the facilities to produce more than 100 motorcycles. Motorcycles was X. So they can't do more than 100, so they have to do less than or equal to 100 motorcycles. Similarly, they can't do more than 240 bicycles, so we know the number of bicycles has to be less than or equal to 240. There's one more constraint in here that's explicit. The total production of motorcycles and bikes cannot exceed 300. So however many motorcycles together with how many of the bikes you make has to be less than or equal to 300. All right, those are the constraints that they actually state. Now, some other things you probably know, is that they can't make negative numbers of motorcycles, and they can't make negative numbers of bikes. Okay, so that's kind of an assumption. These are implicit, sometimes we say. They don't have to tell you that. You know you can't do negative numbers, okay? All right, so now what our job is going to be is to graph the system of inequalities. That's all those constraints. So we're going to do that. We have 4 of them to graph. All right, now the hardest part sometimes is just getting the scale to work out. All right, so let me see. So my Y, I like to label it too. My Y was the bikes. My X was the motorcycles. Okay, so the X and the Y axis, I just want to have that kind of in mind. So I need to get up to around 300, it looks like, potentially. So I'm just going to kind of count here, see what I can do. So that's 1, 2, 3, 4, 5, 100, 200. I could probably do oh. Can't quite easily get to the 300s. I'm not sure I really need to get that far. Let's try it without. If we need to, I'll just extend it. Let me go ahead and just let each of these be 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 150, 200, and then 250. Okay. All right. And then motorcycles probably just need to be a little past 100. So 1, 2, 3, 4, 5. We'll go ahead and do that. 1, 2, 3, 4, 5. Okay, so that's 50. That's 100. So we have more room on that one, but we probably don't need it. Okay. All right. So now all of that just to get ready to graph. So let's look at this now. So I'm going to do these 3 first. So X less than or equal to 100. Okay. X equals 100 would be a vertical line right here. All right, so less than or equal to 100 means I have to be to the left of that. I don't want to actually shade. I just want to remember that. Okay. All right, and then that's the first one. That's the first one. All right, then Y less than or equal to 240, that would be a horizontal line. Okay, that one right there would be number 2. And I'd have to be below that. And notice we only use the first quadrant because you have to make more than, or you can't make negative bikes or negative motorcycles. So that's why you're in the first quadrant. All right, now for X plus Y less than or equal to 300, I might have wanted to use the intercepts, but it would be off the screen. So I'm just not going to. Okay, I'm just going to, for that one, for X plus Y less than or equal to 300, I'm just going to graph some points. If X is 200, Y would be 100. If X is 100, Y would be 200. So there's a couple points I can use to get that line. So 200, 100 is a point I know is on it. And then 100, okay, 100, 200, I should have said, is a point on it. And then 1, 2, 3, 50, 60, 70, 80, 90, this would be 200 out here. Then an X of 200 and a Y of 100 would be on it. And then if you want to, you could pick something in here. Like if I put a 50 for X, then this would be 250. So 50 for X, then I'd be at 250. Okay, so there's the line that represents the total production needing to be less than 300. So that's number 3. Okay, 1, 2, 3, and then I left this one to last. Okay, so Y less than or equal to 4X. I want to graph the line. Oh, I should have finished this one. And then I really want X plus Y to be less than or equal to 300. So I want the ordered pairs to add up to be something less than 300. They would have to be below this line for that to be the case. Okay. All right, now Y less than or equal to 4X. I might just pick some things like if X were 10, then y would have to be less than or equal to 40. And I'm doing the equals to get the boundary, really. Okay, if x were 50, then y would equal 4 times 50, which would be 200. It's going to be a line, so let's get that line sketched. So 10, 40, and then 50 and 200. Okay, and I might want to see what happens if I put, no, I couldn't even do that. If I put 60, that would be 240. So let's see where that is. 60 would hit at 240, should be right there. Okay. All right, so that's the fourth one. So it's 50 times 4, okay, 10, 40. Man, it's hard to draw. Okay, something like that. Let me see if I can erase that first attempt. Yeah. All right, and then if I kept going, it would go down in there. Okay. All right, so here's the thing. If you put those 4, so this is the fourth one, constraints, and get those graphed and do the shading, you're looking for the shading that would satisfy all of them. Okay, so y has to be less than or equal to 4x. I need to decide how to shade there. So you might want to see, whether to shade to the right or to the left. So you might pick a point like right here, 50-50. See that? Might pick a point like 50-50. Is 50 less than or equal to 200? And the answer is yes. So that means I'm going to shade this way on that line. Now, what I need to do is find where's the shading that satisfies all of these. And what I find is that I need to be somewhere in here. Okay, that would satisfy all of them. Okay, so I have that polygon. All right, so now at that point, we're going to look for the vertices or the corner points of this polygon. So that would be these spots right here. Okay. The answer to our question of how many motorcycles and bicycles we should make is going to come from looking at those 4 corner points, okay? And so we're going to list those. So one of them is 0, 0. One of them is 100, 0. I'm just going around the polygon. It doesn't matter the order you do them. Then I have 100, what appears to be 200. And that makes sense. Okay, because 100, 200 would satisfy this right here. Then I'm going to go up to this one, and it looks like it is 60, 240. 60, 240. Okay, and 60, 240 would have also been a solution to that. So that makes sense, that it's a point of intersection. Okay. All right, and so then what I do is I go back and I think about that objective function. The equation for it was the profit equals 1260x plus 350y. Okay, so what I'm going to do is just plug in to that formula. So I'm going to plug in 0, 0, and the profit would be 0. I'm going to plug in 100 for the X. If I made 100 motorcycles and no bikes, my profit would have been this much. Okay, now I'm going to do 100 motorcycles and 200 bicycles. So I'm going to take 200 times the 350 and 100 times the 1260. I get 196,000. And then we're going to do 60 motorcycles together with 240 bicycles. And that turns out to be 159,600. Okay. All right. So now we look at it. And this was profit, so we want to maximize that. So 196, that's the highest value. The maximum value is $196,000, and it occurs when x equals 100 and y equals 200. So we should make and sell 100 motorcycles and 200 bicycles. Okay, so we determined what would be best for our company: 100 motorcycles and 200 bicycles. All right, so that's kind of the example. Now, what happens in the homework is I break it down into pieces. So one problem in homework is just getting the graph of a system of inequalities, okay? Another problem in homework is once you've got a shaded region and all the corner points, can you identify the max or the min from that? Can you take those corner points and plug them in to your objective function? So that's the second problem, okay? Then the third problem, let me think now. Can't remember how they did it. But anyway, the four problems kind of break down linear programming into several different pieces so that you're not doing a complete problem until the very end, okay? And then when you get to problem number 4, you could use this template if you wanted that kind of does a similar thing to what I just did with the motorcycle problem. And you could use it if you wanted to set up question 4. Or if you don't have a printer, you can just do it on paper. But you do want to use graph paper when you're creating these systems so you can identify the point of intersection, okay? So make sure you use graph paper when you get to the problems in the MyLab math course, okay? So this information, what I just did, you can do it on paper. The notes together with the example, get all worked out, together with the work on the linear programming project will get submitted to Blackboard, okay? And then I'll adjust the grade on the linear programming project accordingly. And that's it.